Okay, so we're going to talk about, today we're doing 9-1, and what 9-1 really talks about is intersections and unions of different groups or solution sets. Intersections and unions. So before we get started on that, let's talk about the different groups that we know of in math. So when you're learning to talk, the first numbers that you even start to think about are something called, does anybody know what they are? They are called our natural numbers, okay? These are our natural numbers. Whoops. Calling these natural numbers. Another way we call them is our counting numbers. So, you first start learning to talk, and we start talking about 1, 2, 3, and these are our counting numbers, the numbers we use for counting. And then we get a little bit older, and we move on to elementary school, and we start kinder, and either in kinder or first grade, we all of a sudden start to celebrate Zero the hero. And they make a big deal of it. Okay? And so that group of numbers includes all of our natural numbers, but it includes another number, 0, and those are called what? Yes, Rand? Our whole numbers, okay? So we are looking at our whole numbers. So 0, so when I make this diagram, everything in the outer ring includes what's inside. So really, our whole numbers include 0 and 1, 2, 3. Okay, so that starts about in kinder or first grade. We start talking about whole numbers. Then we get to like 6th grade, 5th grade, and we start talking about another group of numbers. Does anybody know what those are? Sam?
Integers?
Yes, our integers. And how are those different from our wholes? Sam? They include all of the whole numbers and their opposites. So -2, -1, or -3, -2, -1, and also our 0, 1, 2, ... So those are our integers, right? Having a hard time keeping my circle together. And now we get to middle school, and we're in like pre-algebra, and we need more than just negative and positive whole numbers. What do we get to? Henri? Our rational numbers. And our rational numbers, they include all of our integers. Okay, and so they include all of the wholes, the integers, the counting. But what else do they include? What is now added, Matthew?
Fractions and decimals.
Fractions and decimals. Or negative fractions and decimals. So like 1/2 or -1/3. And you said decimals. So like 0 and 3/10. Okay? 0 and 3/10. What about repeated decimals? Would those be considered rational? Does anybody know the definition of a rational? What is the definition of a rational? Hazel?
I was going to say because they can be made into fractions.
And what is the rule?
Anything that can be made into a fraction.
Right, so our rational numbers, the true definition, is any number that can be written as a ratio of two numbers. And a ratio is a fraction. So any number that can be written as a fraction. Can we write 0.6 repeated as a fraction? Or 0.3 repeated as a fraction? What?
I said, yeah, we do 67 over 9.
67 over 9? would I put 60? So what is the fraction quantity for 0.6 repeated? Is there a fraction quantity? Sam? It's 2/3. This should be memorized, absolutely. We can write it as a fraction. Any repeated decimal goes over 9. So it's 6/9, and that reduces to 2/3. 0.3 repeated is 3/9, and that reduces to 1/3. So absolutely, our repeated decimals are part of this group. Yes?
Also, numbers like 0.32 repeated would be 32.
Right. So 0.32 repeated. So any type of, our rationals include any number which can be written as a fraction. So that means fractions, decimals, repeated decimals. We call this kind of decimal right here a terminating decimal because it has an end. This goes on and on forever. That's called a repeated decimal. But repeated decimals can be written as a fraction. Is everybody clear on that? Now, there's another group. They're not part of the rationals, and they're off over here. Does anybody know what they are called? Let's go, Gabrielle.
Irrational numbers?
What?
Irrational?
Irrational. Irrational numbers are not part of the rational family. So there's two different families, rational and irrational. And our irrational numbers are some examples, Carson. Pi. Now we write it as a fraction, 22/7, but when you divide it, it goes on and on forever. And we cut it off at 3.14 so we can use it for measuring purposes. But it goes on and on forever. Yes. Okay. What is that? The square root of? No. Tau is, it's, I think, doubled, right?
Yeah.
Which is double pi. So how do you write it as?
Just a T.
T. Okay, so what about numbers that you see in our world today that you have dealing with, not above and beyond this class? Yeah.
I was going to say square root of -1.
Good. Okay, not outside of this class. Stuff that you should have learned. There are way more irrationals than the square root of -1. And the square root of -1 is not an irrational. How about this? The square root of 2. The square root of 6. Sorry. The square root of 8. Any non-perfect square is irrational. When you type that into a graphing calculator, it'll go on, and then it'll cut it off at like the 8th digit. And so our irrationals are really just these non-perfect squares. Okay? Now I know pi, we can write it as a fraction, but if you divide it, it would go on and on forever with no pattern. No particular, it's not a repeated pattern, okay? Now, together we call these two groups what? Anybody? We say it a lot when we're talking about domain and range. Sydney? These are the real number system. These are called real numbers. So part of the real number system are our rationals and our irrationals. Within the rationals are integers, wholes, and naturals. Yes?
What's an example of an unreal number?
Okay, so Sam, you want to talk about that? What would be an example of a not real number?
The square root of -1.
The square root of -1. Can we take, okay, let me give you something. How about this? Let's do this. The square root of -4, right? We can't take the square root of, because no number times itself will give us a negative, right? So this is what we call an imaginary. Okay? Square root of -1. Anytime I'll show you how to break that down later. We really represent it by an I. Okay? So these are outside of our reals. Do you understand that? So when I tell you all real numbers. When we're saying that, when we talk about the domains, we're really talking about any rational or irrational number. Okay? Yeah.
What about anything like 4 divided by 0?
That is undefined. Okay? Undefined. So not part of that. So let's continue going. This is really our warm-up and our review of pre-algebra. Is everybody remembering these number groups outside of the imaginary numbers? That's not. All right, so 10 minutes just for our warm-up. So now we get to our lesson, which is, we are talking about, this is section 9.1. Homework today is page 403, number 1 through 42, all in the green book. And we are going to start talking about sets. So a set is a collection or of members or elements in a group. Okay? When I talk about members of a group, one way we can look at it is just take it to our real life. And let's look at, let's say, the colors of the rainbow. Does anybody know the colors of the rainbow? Who are the members or the colors of the rainbow? Let's go Geneva, sorry.
Red, orange, yellow, green, blue, indigo, violet.
Perfect. So we can look at those like those are members of a group. Okay, how about our vowels? Our vowels. Jesse Hawk. And just our normal ones. Yeah.
A-E-I-O-U.
Yeah, these are the members of the vowel set. Does that make sense? Or the elements of the vowel set. Set of Beatles in the band. And there's only one way to say it. So unless you can say it the right way, because there's only one way we refer to the Beatles, who are responsible for the music you listen to today. What do you think?
John, George, Ringo.
Oh, you killed me. You killed me. You didn't say it right. On the recording, you didn't say it right. Anybody know how to say that? Okay, it's almost like a rhyme. It should be shameful that you guys don't know this. Okay? It is John, Paul, George, and Ringo. Everybody say John, Paul, George, and Ringo. Okay, now that they've mastered it, I'll put on pause. Hold on. Nobody needs to say anything else. When you say those words, we all know who you are talking about. Got it? No John Lennon needed. No Paul McCartney needed. John, Paul, George, and Ringo are the Beatles. Yes. Hold on, I gotta. Okay, so now let's talk about a set with no members. Can you think of one? A set that has no members. How about the number of students that will be spending the night at school tonight? I mean, the students that will be spending the night at school, not the number, but there's nobody here, so that's not going to happen. That would be an empty set. A spider with 10 legs, they don't exist, so that would be an empty set. Okay, that would be a set with no members. Now, somebody said the band Nirvana. The problem is that band does have members. It's not an empty set. One of the members may have passed away, but you know that band did exist and has members. Okay? So now we're going to jump to our operations with sets. Okay? You can write this down for the next two sections. All right, so the first group of sets that we're going to be looking at are called intersections. Now notice the symbol that we use. And it doesn't normally come with the parentheses around it. You don't need to write it with the parentheses. Okay? And these are going to be very important when you see the word and. We are talking about intersections. And will become very important later. When you see that word, we're talking about intersections. Okay? Now, when I talk about an intersection, what I'm really talking about, the elements which are in common. The key word being common. Sometimes I use the word commonality. Who is part of both? Okay? So when I say A intersecting B, what is the commonality between A and B? And notice, because it's got this symbol, it means intersection. So A intersection B, what is the commonality? Yeah.
4.
Okay. So A and B, 4 is in common. Anything else?
2.
Phoebe?
2.
2. So you would write 2 and 4. If you leave one of those members out, it'd be marked wrong. Okay? Because you're not giving me the set that's in common. It's a set. You don't do part of a set. So if you leave 2 out, it would not be accurate. Okay, 2. Why don't you guys try 2 and 3? Pause the recording and do 2 and 3 on your own. Okay. So remember, Max, an intersection is what's in common. So what is the intersection of B and C? What is in common? What is part of 6 and?
6 and 6.
Well, 6 is in common. I don't need to write it twice. And what else is in common? There's another number.
8.
8. So 6 and 8 are the intersection. Because that's what's in common, the commonalities. Okay? Gael, what is the intersection of A and C? 5 is the only number they have in common, so I'd list it like this. All right, now look at this. This is like the intersection of A and B first, parentheses first. So what is the intersection of A and B? Rand?
2 and 4.
2 and 4. And the set of C, I just listed. So really what they want to know is, what is the intersection of both these sets? Josh? None of them. And so we say that that is an empty set. And there's 4 ways to write that. The first way is with empty braces. The second way is with the word empty set. The third way is with this symbol, which really means null set. And the fourth way is just to use the word null set. So one of those 4. Do not take one of these and put that inside of the braces. Do not take empty set, the null set symbol, or the word null set and put it inside. Because it's like a double negative. And in math, it's wrong. Okay? And Miss Sophia will definitely mark that wrong. You will lose big points for that. Putting empty set inside the parentheses. Braces, sorry. Okay, questions. Okay, all right, let's continue. So now we're going to do a different kind of set, and these sets are called unions. This time, the symbol for a union is a big U. And a union, what are your thoughts on that? What do you think, who do you think is part of that? Yes?
Is a union like something that's like combined?
Combined, it's the combined set of both, without repeats. Okay? For instance, if you are in my 4th period, or let's say, if you are in one of my classes or you are in musical theater, you are invited to the dance tonight. So only musical theater and my students, raise your hands. If you are in musical theater or are in one of my classes, let me see who is invited. I need a show of hands. I don't see all hands up. Gael, are you invited? Is Hannah invited? You're not in one of my classes?
Not a musical.
But you're in one of my classes. Are you invited? So anyone in any one of my classes or musical theater, Amri, are you invited? That means everybody in here. That is a union. However, if I said only, I'm creating a field trip, and only Math Academy students in my class are invited. Only Math Academy, in 4th period. Only my Math Academy if you are in my fourth period, are invited on this field trip. So who are the students? Now that is an intersection because they fit both groups. They have both groups in common. Does that make sense? Okay. So our unions, we're looking at A union B. That means we are combining. So what would I, without the duplicates. So what would be in that set? A union B. Shoshi. Shoshi.
Would it be 1, 2, 3, 4, 5, 6, 8, 10?
Yep. We're just combining. Now I don't write 4 or 2 twice because imagine if I said my students in musical theater are invited. Who's in musical theater here? So all these musical theater people are not walking into the dance twice. They only get counted once. Do you understand that? Okay? So that's why we don't write the repeats. Okay, you guys try and find the union of B and C. B union C. And A union C. Okay, Ashley, what would we say for the B union C?
You would say 2, 4, 5, 6, 7, 8, and 10.
Perfect. Questions? I'm combining them both. Sydney?
I don't get this. Like, I got the first and I got intersection, but I don't understand.
All we're doing is I'm inviting, okay, so when it says B union, it means I'm inviting the people that are in this club and the people that are in this club, okay, B union C, and I'm putting them into one group.
Oh.
So it's just the combination of both. But Sydney, I don't need to invite 6 twice. There's only one body,
I understand it now.
okay? Good, I'm glad you clarified. Jesse.
Can I do number 3?
Yeah, well, actually, why don't we have Sydney try and do A union C?
1, 2, 3, 4, 5, 6, 7, 8.
Perfect. You guys got it? So unions, a union is when we combine them. An intersection is only what's in common. Geneva.
Do they have to be in numerical order?
You should put them in numerical order or you will make your future teachers nuts. Grading 200 papers, looking for the one missed number. So if you put it in numerical order, not only that, it will keep you. All right, I'm going to skip the part on Venn diagrams because we're not really covering that. I mean, I can briefly go over it right here, but I just don't want to spend a lot of time. Let's say I list my members of A. B are these. And the intersection, notice it should be in both circles. And we show the intersection by shading the part that is inclusive to both. Yes?
Can we answer it that way on the homework?
No, I don't want you doing, we're not doing Venn diagrams because these get very complicated. I know it looks like it's very easy. When we talk about a union, I list all my elements. We know that these two are in common. But in this case, if a union, it's shading all. And I know this looks very simple, but they really start to get very complicated. Okay? So you'll see here the intersection of all three. What intersects in all three? Nothing. This is, first the intersection of these two. The union of those two. But only the part that intersects C, so it would just be here. So these get very complicated. I'm not going to really get into that, okay? Let's keep going. Now, for tonight, we may need to do some, but it's the last part of this that we're going to, so this is the beginning part of this chapter that we'll eventually end up using. So when I say x is all real numbers greater than -4, how would I show that on a number line? X is all real numbers. Matthew.
Wouldn't you do the open circle and a line to the right?
And open circle at,
-4.
and I would go to the right because it's greater than. So does that mean -4 is included in this number set? No. And that's why it's open circle there. But if it says all real numbers less than or equal to 1, what would that look like? How about Jabril?
I'm shading the circle under 1
And which direction?
to the left.
And this time we're going to the left. Okay, we've been doing that. That's pretty normal for what we've done already. Now, here it's a little bit different. All real numbers between -2 and 3. How would I show that? Carson?
That'd be with -2, it's an open circle, and then to 3, it's another open circle.
And we connect them.
And, yeah.
Good. So it's an open circle. And you will also notice something else here. It has the word and. And. Where else did I tell you that that word would be important? Intersection. Intersection. So the intersection is just, it's going to look like one line between certain numbers. Now, because -2 and 3 are not included, these are open circles. Okay? All right, now here's where we get to our homework. Okay? Set builder notation. The word notation means writing. It's a form of writing. It's how we write things in sets. We've been doing roster notation. That is what we've been doing. When I ask you for the list of solutions, you give me a list of numbers. That's roster notation. You've been doing that. In set builder notation, we really talk about the rule. So what group is this part of? What group is 1, 2, 3, and 4, and 5 part of? Hazel? The natural numbers. You don't need to say both. You could just say natural. Are natural. So here's how we write it. You're going to write it just like I'm writing. We're going to say, first they called it set A. In set A, X is such that, X is such that, X is a natural number. Now see that colon? That means such that. That's what we read that as such that. Okay, and it's just a fancy way to say it. And another way to write it is also with a line. You can write it like that. X is such that X is a natural number. Now, we also show it with an inequality. Okay, and that inequality, X is such that X is less than or equal to 5. Are you writing this, Connor? Thanks. Okay, X is less than or equal to 5. So notice, the group they belong to is natural numbers, and then I'm showing that it's less than 5. Now I have two boundaries here, because the natural number is my lower boundary. That's where the numbers start at 1, not at 0. And this tells the maximum number in that set. So this is set builder. It really just talks about the rule. Rewrite the group and the inequality. Now, in roster notation, 4, 5, 6, 7, for set builder, it's still, these numbers are still part of the natural numbers. Only this time, what's my inequality going to look like to describe 4, 5, 6, and 7? Yes.
4 is less than or equal to X is less than or equal to 7.
Yes. Remember when we did those in-between statements? 4 is less than or equal to X, which is less than or equal to 7. So I'm writing the group and the inequality. I could have written this, but it takes a lot longer. I could have written X is greater than or equal to 4 and X is less than or equal to 7. But do you see how that makes it so much less? It's abbreviated, hence the beauty of math. Okay? I wouldn't mark you wrong if you did it the other way. All right, so now we are, so if I'm using roster notation to describe A, what is this? Intersection B. What is the intersection of A and B? Is that what's in common or is that combined? Common. So what would it be, Phoebe?
4 and 5.
4 and 5. It's only what's in A and B. Okay? And what about A union B? Yes.
1, 2, 3, 4, 5, 6, 7.
Yeah, that's the combining A and B. Okay? Questions? Okay. Now, here is what the homework's going to be like. And also, this is the way I could ask you on a test. Now, if you don't understand these words, you will lose massive amounts of points. Because if I put 5 of these on there, notice in part A it says roster notation. That means we're just listing numbers. But if you put roster notation under B, do you see how this could be a loss of a lot of points? You have to understand and know what roster notation is. And you have to understand what set builder notation is. Are you with me? Yes or no? Okay, so let me tell you what this means. This little weird looking E is an element of or a member of. That means is a member of. So if they give you X is an element of the whole numbers and is less than 5, then for A, how am I going to list this in roster notation? How are we listing that in roster notation? Anybody? Let's go, Geneva.
It goes like 4, 3, 2, 1, 0.
0, because 0 is part of the wholes. So 0, but we would put it in order from least to greatest. 0, 1, 2, 3, 4. Now, would I mark you wrong? No, but it will start to get to us, okay? Now, how do we write the set builder notation? We always write X is such that X, right? X is such that X is, and we write the rule. What group? So X is such that X is a whole number. And how do I show the second half with an inequality? I write and, yes?
X is less than 5.
Yep. So they give me everything I need to do this. The answer is in the problem. What group? You just have to remember to do X is such that X is a whole number. And turn this into an inequality. You guys good? Jordan?
I think so.
Okay. Okay, so what is the roster notation going to look like for number 2? How about Ella?
The roster notation. Hold on. So would it be
Between -3 and 2.
-3, -2, -1, 0, 1?
Okay, who is sitting between you and Anna?
Hannah?
Yes. So are you in that number set?
No.
Okay, so one more time. An integer between -3 and 2.
-2, -1, 0, and 1.
Perfect. Okay, now let's go to B. Set builder notation. Jordan.
So you do X is such that X is an integer and -3 is greater.
No, we always do
Is less than. That's what I meant to say.
less than.
Is less than X, which is less than 2.
Perfect. Do you guys understand? Is this clear, Sydney?
Yeah.
Okay. Okay, roster notation for naturals that are less than 7. Matthew.
1, 2, 3, 4, 5, 6.
Good. And then set builder notation for part B. Set builder notation. Connor.
X is such that X is a natural number and X is less than 7.
Good. And the boundary is there. The natural tells me I don't include 0, and this tells me the maximum. X is less than 7, shows me 6 is the maximum. Okay, I got one more slide I want to go through. Are you guys clear? Does everybody understand set builder versus roster? Okay. Just look at the question. All right, so I've got 3 sets, and you got to know what holds, where that begins. Where do those begin? Jesse? 0, 1, 2, 3, blah, 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 right, etc. Okay, what does this mean? Intersection of A and B. What do they have in common? The whole numbers and these numbers. Yes, they do. I know there's a typo there. Josh? 0. And they just want it in roster. Okay, B union C. B union C. Rand?
0, 1, 2, 3, 4.
Good. So we're just putting the union of both. B intersecting C. Matthew?
Empty set.
Empty set. Good. Because there's nothing in common. A union B. Now look how we write this. The wholes start at 0, right? 0, 1, 2, 3, 4. But so I'm going to list these first. And then I'm going to continue into my holes and show a dot, dot, dot in the whole direction. Does that make sense? And then A intersecting C. The intersecting is just what they have in common. Jesse?
1, 2, 3, 4.
Yep. And that's your lesson. So, okay.